So let us look at our last question. It comes from the November 2016 paper, and it's actually such a nice little question. It really is. And really, I think all of you should be able to cope with it now at this stage. So let us have a look. Remember to take a photograph of it so that you can work through it with me and that it's not too difficult to follow. All right, so let us have a look. Question 4 says, a ball is dropped from the top of a building 20 meters high. Ignore the effects of air resistance. All right, so let us have a look. And there's the diagram. All right, so simple, and that's it. All right, so obviously I can see the building is 20 meters high, and there's my ball that is being dropped. All right, so just looking at this, the ball is dropped. So what is that telling me about the object's initial velocity? So the initial velocity is going to be 0. All right, and because it's been dropped, I would like to select the downward direction as the positive direction. So always make a list of what has been given to you. What information do I have? So when you get onto the questions, you can actually go and identify the equation you need to use, because very often it is confusing if you're not sure which equation to use. So always make a list of all the physical quantities, and then you can go and identify the equation. All right, so let us have a look what we have. So the initial velocity of the ball is 0. We're taking down as positive. So remember, because it's in the air, we've got g is equal to 9,8 meters per second down. They're telling me that the height is 20 meters. So guys, we've got the displacement, we've got the height is 20 meters. So with these equations of motion, I'm not sure if you realize, but there are normally 4 physical quantities in every single equation. So I need to have 3 facts or 3 physical quantities, then I can solve for the unknown. All right, so if we've got 3 variables, we can solve for the 4th one. So I see here, I've got the initial velocity, I've got g, and I've got the displacement or the height. Therefore, I can actually go and work out something from that information because I've got 3 pieces of information. All right, so let us look at the questions. All right, so the first question asks, oh gosh, I'm not too sure what is on here, but let us just erase this. There we go. Okay, so I don't know what happened there. Okay, so now it says define the term free fall. All right, so what is free fall? So free fall is when any object is in the air, it is in free fall, that the only force acting on that object is the force of gravity. All right, so when something's in free fall, the only force acting on it is the force of gravity. Okay, so there we go. That was our definition. Next one says, calculate the speed at which the ball hits the ground. So they're wanting us to calculate the final velocity. So we have the initial velocity, it was dropped. We have g is equal to 9,8, and we know the displacement in the air was, or the height of the building was 20 meters. So there's all my information. So now you need to go to your information sheet. So if I can find it here. Now we're going to go to the information sheet and we're going to have a look which equation. So would I use this one here? No, I won't. Why won't I use it? For the simple reason is that I've got the displacement. I've got delta y equal to 20 meters. So nowhere in this equation can I use that piece of information. So that's not going to help me at all. All right. If I have a look at this equation or this one, it's exactly the same. That is just representing if it's in the x direction. This is representing if it's in the y direction. But yes, I think this would work because I've got A, I've got G, I've got the initial velocity, and they're wanting me to calculate the final velocity. So that is what they're asking me to calculate. So this makes a whole lot more sense. So that is the equation I'm going to be using. All right. So we go back to our question. Just need to select my pen again. So we're going to go with delta y. Sorry, I'm getting myself confused here. We're not going to use that one. We're going to go with v final squared equals v initial squared plus 2g delta y. So final velocity is what we're wanting. V initial was 0 plus 2 times 9,8 times 20. All right, so V final squared is equal to, so we need our faithful calculator. So we're going to have 2 times 9.8 times 20, and that is equal to 392. And now we're going to take the square root of 392. So the square root of 392 is equal to 19. All right, so it's equal to, and I lost the last commas there, comma 798. So let's make a comma 80. So comma 80 meters per second. Now, what I saw on my calculator is what it gave me my answer as a third. Please remember, you may not leave your answer as a third. So you can't say 4 square root 10 or whatever the case is. You have to give your final answer to 2 decimal places. So remember, it's always important to read the front cover of your information sheet. Always read the instructions, and there the examiners are telling you exactly what you need to do. And if they say, please work to 2 decimal places, then you work to 2 decimal places. Please, please, please. Never leave your answer in a third form or as an improper fraction, whatever the case is. So always give it as a 2 decimal place answer. Okay, and there we go. So that was an easy one. Let us look at the next question. The next question says, calculate the time it takes for the ball to reach the ground. All right, so once again, what information do I have? Well, now I've got the final velocity is 19,80 meters per second downwards. The initial velocity, it was released from rest. The time is what they're wanting. And I have G is equal to 9,8 meters per second per second. So just once again, just looking at our information sheet. So in order to use it now, so let us clear all this clutter that I put on here. All right. So if I have a look now at the information sheet, this is the one that is going to be the most useful. I've got V final, I've got V initial, I've got A, and I'm wanting delta T. So yes, you could use other equations, but this is really a simple one to use, so I would rather us go with that equation. All right, so let us have a look. Just need to select a different color again. So we're going to go V final equals V initial plus A delta T or G delta T. V final was 19,80. V initial was 0 plus 9,8 delta T. So now it's easy. So we're going to have delta T equal to 19,80 divided by 9,8. And our faithful calculator, always make sure your calculator has got new batteries, that you don't run out of a calculator during exams, because that would be disastrous. So always have a look that you have enough battery power. And that's equal to 2,02 seconds. And there we go. Yay. So this is a really nice little question. Okay, so hopefully we're not having any problems with it. And it's amazing how always at the end of this type of question, they will put in the graph. So yes, there's a graph question. All right, so let us look at the graph. It says, sketch a velocity time graph for the motion of the ball. No values are required. All right, so this was a really, really nice little one. So they said no values. So we got velocity, meters per second. We took down as positive. This is time in seconds. So this ball was released from rest. So we're starting here, and it just increased until it hit the ground with the maximum velocity. And because they said no values required, that's all you have to do. All right, so a really nice little question, straightforward, and no little tricks to the trade. All right.